Hello, this is Dr. Brown. This is going to be a very quick review of some of the fundamental concepts that you need to understand on Test 1. One of the things you will definitely have on the test is to calculate the average rate of change of a function. This is really one of the starting points for differential calculus, just to be able to calculate what we call the arc, or the average rate of change of a function, as x goes from, say, x1 to x2. And the average rate of change, in this particular case, we're going from 1 to 3. The average rate of change in this equation you definitely need to remember, not just memorize, but understand the concept. And it's f of x2 minus f of x1 divided by x2 minus x1. It could also be, if you're talking about distance s, it could be s of t2 minus s of t1 divided by t2 minus t1. Okay? You can also write it as y2 minus y1 over x2 minus x1. So the first thing to do is take x2, which is the last point in the interval, and plug it into the function, and you get 10 over 3 squared plus 1. Then plug in x1, and you get 10 over 1 squared plus 1. Calculating all of this, you get minus 2 as the average rate of change, which really is telling you that the function is decreasing on the average on that interval. The other thing you'll be doing is to calculate limits using various methods. A lot of times we want to calculate the limit of a function, f of x, as x approaches x naught. Sometimes that will be written as c. It doesn't really matter. But if the limit exists, you write it down as L. Now, as we said in the videos, quite often all you have to do is plug in x naught in the function. If you can calculate it without doing something in which you're dividing by 0, which you can't do, or getting some other expression that you don't quite understand, if you plug it in and you can calculate a number, then that's going to be the limit. And that's the case for quite a number of functions. And in this case, plugging in x equal 2, you get 8 minus 8 plus 3 equals 3 is the limit. Another example is when the function has like a hole in it. In other words, at the point minus 5, the point minus 5 is not on the graph. But if you take a look at the numerator, you might find that x plus 5 is a factor of the numerator also. So go ahead and factor it to see if you can reveal that. In this case, it's x plus 8 times x plus 5, and lo and behold, you can factor out the x plus 5 and get x plus 8, which you can plug minus 5 into and get 3 as the limit. Now, the next one is, sometimes I call this using sort of a trick, but it's a pretty neat trick that can often work for you. If you have a radical minus a number, or a radical or a number minus a radical, what you do is take, for instance, in this case, the radical in the denominator, which is x minus 1, and calculate its conjugate, which is the square root of x plus 1. So now you will multiply the numerator and the denominator with the radical x plus 1. And then what you do is you take the radical minus 1 and the radical plus 1 and multiply them together first. Don't do anything with the top, because you'll find very quickly you'll get some simplification. So multiplying radical x minus 1 times radical x plus 1, you get radical x times radical x is x, plus the outside is 1 radical x, the inside is minus 1 radical x, which cancels, and the last term is minus 1. And notice you get cancellation, and you're left with the square root of x plus 1. And now all you need to do is plug in x naught, which is 1, and you get the square root of 1 plus 1 equal 2. So you need to know how to use that technique. Another function that you'll probably have to calculate limits with is like the sine function. And to help you remember how to do this, remember I said that sine of anything, if that anything is approaching 0, equals anything. For instance, the limit of 6x plus sine of 10x over x as x approaches 0. Notice you can't put 0 in the denominator, you can't divide by 0, but notice, go ahead and divide x into each of these terms, and you get 6x over x plus sine of 10x over x. That would be 6. And remember, as 10x is approaching 0, sine of 10x approaches 10x. And notice, writing 10x divided by x, you get plus 10. So the limit is going to be 6 plus 10 equals 16. Another example, the limit of 6x squared plus sine of 5x over x as x approaches 0. Again, divide x into each term in the numerator, and you get 6x squared over x, sine of 5x over x. This is equal to 6x. And then you have, as 5x approaches 0, sine of 5x equals 5x. And now, as x approaches 0, you get 0. The x's cancel, and you get 5, so the limit is 5. Now you're also going to have to understand the limit of functions as x approaches infinity. And quite possibly we're going to be looking at some rational functions. In this first case, we've got the limit of 3x cubed plus 4x squared minus 2x plus 1 divided by x cubed minus x squared plus x minus 2. As x goes to infinity, and you remember a polynomial, as x goes to infinity, you can take a term with the highest degree, and in this case, neglect the rest. So we plug in the highest degree term, 3x cubed. The numerator is 2x cubed. The x cubes cancel, and you get 3/2 is the limit. You might remember that for a rational function, if the numerator and denominator have the same degree, all you have to do is to take the coefficient of the first term and divide it by the coefficient of the first term in the denominator. So that's 3 divided by 2. Now, here's another one in which we have a second degree divided by a third degree. Probably should remember that if x is going to infinity, then the third degree is going to overcome the second degree and it's going to go to 0. And that's exactly what we see if we take 10x squared, the leading term of the numerator, and 5x cubed, the leading term of the denominator. That equals 2 over x. Obviously, 2 divided by x as x goes to infinity is going to go to 0. Then we've also got limits that can go to infinity. And this is just a simple example of a rational function that has a vertical asymptote at x equals 3. And now we want to know what happens to this function as x approaches 3 from the left. And notice that all we need to do is get on the function, come from the left, and notice it's going to minus infinity. For the limit of f of x as x goes towards 3 from the right, you can see it's going up to plus infinity. Now, a very important thing that you need to be able to do is to calculate the slope m and the equation of the tangent line at the point x0 and y0 of a function. You can remember, and you will have to understand and remember this formula. The slope m of a tangent line is the limit as h approaches 0 of f of x plus h minus f of x divided by h. Obviously you can't put 0 in the denominator because you'll be dividing by 0, but you will find if you take a whole lot of functions and try to calculate this limit that you can do it, and all it requires is for you to understand how to do some simple algebra. So in this particular case, I suggest calculating f of x plus h minus f of x divided by h, and then it works for any x. So I could do it for just 2 and just put 2 in here, and that would get it only at the point 2 and 13. But I suggest, and it's going to always be simpler to do this, to put x plus h, and then your answer will work for any x. So now, limit as h approaches 0, plug in x plus h everywhere you see an x, and you get this, this, and this, and then subtract off f of x, which is simply 3x squared minus 2x plus 5. And now you just use some simple algebra and expand x plus h squared and take minus 2 times x plus h and plus 5, and then subtract off f of x. And then multiply everything out and you get 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 5. Subtract everything else off, and notice some nice things will happen. The 3x squares cancel, the 2x cancels, the 5 and minus 5 cancel, and we're left with 6xh plus 3h squared minus 2h divided by h. And notice the neat thing here is you can factor an h out of the numerator, and when you do that, you can cancel the h in the numerator and the h in the denominator, and you're left with 6x plus 3h minus 2. Excuse me, getting ahead of myself. So we have 6x plus 3h minus 2. As h goes to 0, that goes to 0, and we're left with 6x minus 2 is the equation that gives you the slope for any value of x. And so now plug in x equal 2, and you get 12 minus 2 equal 10. So the slope of the tangent line is equal to 10. Now you want to write the equation of the tangent line. Well, you know the slope, so you know you can write y equal mx plus b. The slope is 10, so it's y equal 10x plus b. To get b, we need to plug in the point 2 and 13. So we plug in 13 for y, 2 for x, and solve for b, and we get b equal minus 7, and we have y equal 10x minus 7 as the equation of the tangent line. Another thing I wanted to do was just illustrate a simple function and talk about the relative values of the slope of the tangent line, which we also call the instantaneous rate of change. And the slope of the tangent line is also called the derivative at that point. So you probably should get used to thinking of all these three terms as being equivalents. Now, what I like to do is look at all these points and then imagine a tangent line. And a tangent line just touches the curve at one point. So we can just go and draw tangent lines. And I'm not a great artist, but here's a tangent line at G, a tangent line at A, a tangent line at C, and a tangent line, if I can keep everything here, a tangent line at E. Now, where do you see zero slope? Well, you just see it at D and B and F. Where do you see a large negative slope? You see it at A. A large positive slope would be at G. And a moderate positive slope would be at C. A moderate negative slope would be at E. Notice I have, for some reason, duplicated these two things. The large positive slope is at G. Now, another thing you're going to do is probably you'll see some graphs presented to you on the quiz, and you need to evaluate function values and info on limits. And I've got a couple of examples, and you've had plenty of them in your homework. Here is a function, f of x, and it's got a hole in it at 2 and 4. Because we have a heavy dot here at 2 and 8, that indicates that that point 2 and 8 is on the graph. However, the rest of the graph is very nice, and there's only one place where there's a hole, and that's just the point 2 and 4 that's not there, and we're asked to find the limit of f of x as x gets closer to 2. Well, don't make a mistake and say the limit is 8. That's the function of at 2, but as x gets closer and closer from both sides of 2, gets closer and closer to 2, it approaches 4. So the limit is 4. Another graph here. We have a hole in it, and we have a point here that's on the graph. Notice that this function is very jumpy and not continuous. Function of 3 is equal to minus 2. That's just because there's a heavy dot there, a filled in dot. The limit of f of x as x approaches 3 from the right. You need to get on the curve and go towards the right. You see it approaches minus 2. And the limit as it approaches 3 from the left is 3. So you may have several like this. Now, if you're asked now, what is the limit of f of x as x approaches 3 without indicating right or left, you say does not exist. In other words, since the right hand and the left hand limit do not agree, then the limit as x approaches 3 does not exist. You need to remember that. There are others that involve average and instantaneous rate of change. Here we're talking about not a function of x, but a function of t, where s is the distance and t is the time. And turns out on Earth an object falls at a distance given by s equals 16t squared, where s is in feet and t is in seconds. What is the average rate of change from t equal 1 to 5 seconds? Here again, you just plug in 5 and then plug in 1, subtract them, the two functions at the 2 points, and then divide by 5 minus 1, and you quickly calculate it's 96 feet per second was the average speed of that object falling over a period of 4 seconds. Now, what is probably even more important is what is the instantaneous rate of change at t equal 5, and that is where we use the instantaneous rate of change. This is also called the slope of the tangent line. And let me get it back. Plugging that in, we get s of t plus h minus s of t divided by h. As h approaches 0, plugging in t plus h into t squared, we get t plus h squared times 16 minus 16t squared. Very quickly, you see you subtract off 16t squared, and you're left with 32 th plus 16h squared. You can factor the h out, and there again you have relief from the problem of dividing by 0. You have an h in the numerator and the h in the denominator that cancel. Now you can plug in h equals 0, and you get 32t. It tells you what the velocity is at any time, and at 5 seconds it's 160 feet per second. And then vertical and horizontal asymptotes will probably have some functions. In this particular case, the functions are r of x, which indicates rational functions. And vertical asymptote is when the denominator equals 0 and the term in the denominator is not canceled out by the same term in the numerator. So watch out for this. In this case, we're going to factor the numerator and get 3x times x minus 1, factor the denominator and get x plus 4 times x minus 3. Notice that none of the terms are canceled. So we have two vertical asymptotes. And we just set x plus 4 equals 0. We get x equal minus 4. X equal minus 4 is the equation of the vertical asymptote. Don't just write down minus 4. Write down x equal minus 4. The other one is x equal 3. Is a vertical asymptote. And notice we have a horizontal asymptote. If you look at the original equation before we factored, you get 3x squared minus 3x over x squared plus x minus 12. And the vertical asymptote is going to be the ratio of 3 to 1. And so now you write down y equal 3. Don't just put 3, put y equal 3 as the horizontal asymptote. And now you can graph it. You could put this in your calculator and you see the graph of this rational function. Now the last term, a problem we're going to have is one where you want to watch out if there's a cancellation in the numerator and denominator. So here's another rational function. We can factor x squared minus 4 into x plus 2x minus 2, and then factor the numerator into 2x minus 1 times x minus 2. Notice x equal 2 is not going to be a vertical asymptote. It's just going to be a hole in the function. So x equal minus 2 is the only vertical asymptote. Also notice that the horizontal asymptote is going to be y equal 2x squared over x squared equal 2. So that's the horizontal asymptote. So now if you graph the function, you get a vertical asymptote at x equal minus 2 and a horizontal asymptote at y equal 2. Okay, that is all for now, and call and ask me any questions you might have.